I have got to tell you a silly story because it's going to sound like I'm whispering. I I share an office with somebody, and I didn't want to be in the middle of recording my video and her come in and start talking. So I was like, I'm gonna go to the library and I'm gonna see if they have a quiet room I can go into. And they said yes. And so I rented a room and I didn't know where it was. And they're like, okay, just go here. I said, okay, great. Well, I had to walk through somebody giving a presentation to get to this room. And then, I don't know if you can hear it, but they're giving a presentation, and I'm hoping you can't hear it in the background. And it was so awkward. And I'm sitting in here. They have big glass windows, and I'm hiding in the corner so that these kids are not paying attention to me. So, this is just fantastic. And then when I'm done with this video, I have to walk back out through them. And then I was embarrassingly struggling with getting the door open. Okay, let's try and get through the sum and difference. So we're gonna use these things to find the exact values of these. Yeah, you can plug it in the calculator, you'll get some weird decimal, but I don't think you know how to turn the decimal into the exact value. You know, like, let's just say you get 2.37 and it just keeps going, whatever. I'm not gonna say you don't know how to, because maybe you do. I can't think of a way right now. But, you know, what if the answer is like square root of 3 plus square root of 7 all over 6? You know, you won't be able to get from the decimal to that very easily. So we want the exact value, not the decimal approximation. So what we can do, 105 is obviously not a number on the unit circle. So what we can do is break it into ones that are. So I could say, instead of 105, I could say that that's 60 plus 45. That'll give me 105, and 60 and 45 are on the unit circle where I can get the exact values. So, because I'm adding the two, I could use this formula. So sine, and the order doesn't matter, sine of 60 plus 45 is going to equal, let's see, sine of A, so sine of 60 times cosine of 45 plus cosine of 60 times sine of 45. And we can use the unit circle to get these exact values. So sine of 60 is root 3 over 2 times cosine of 45, which is root 2 over 2, plus cosine of 60, which is 1/2, times sine of 45, which is root 2 over 2. So I'm going to multiply these. So that's root 6 over 4, and then that's root 2 over 4. And I can combine it into one, root 6 plus root 2 all over 4. And that is the exact value. Okay? All right, now we're going to look at a cosine one. So cosine, let's see, how can we break up 165? Honestly, it's just going to be guessing and checking on some stuff. How about 45 and 120? So I'm going to use the cosine one now. So cosine of 45 plus 120 is cosine of 45 times cosine of 120 minus I wish you could hear what is happening outside this room. I'm really hoping that shows up because she's kind of loud on that one. Sine of 45 times sine of 120. Okay. I'm never renting a room again. Okay. What's even going to be even better is I don't watch his videos back. What if I'm laughing at myself and there's actually no background noise? You're going to be like, what the hell? Okay. Cosine of 45, looking at my unit circle, is root 2 over 2. Cosine of 120 is negative 1/2. And then we're going to minus sine of 45, which is root 2 over 2, times sine of 120, which is root 3 over 2. So I will multiply these. So negative root 2 over 4 minus root 6 over 4. So we get negative root 2 minus root 6 all over 4. Okay. We can do it with radians as well. But I think the easier thing to do, so you don't have to deal with trying to get a common denominator for all the possible fractions we have in the unit circle, is what if we get this into degrees? So 19 pi over 12, let's get it to degrees, so times 180 over pi. So let's see, the pi's will cancel. And then I'm going to do 19 times 180, and then I'm going to divide that by 12. Wow, okay. And then I get 285. So I got to think about how can I break up 285? Let's see. 330 minus 45? 330 minus 45. Let's see. Oh, one cool trick. And, you know, it can be whatever kind of trick you want to think about it. But what if I did 329 minus 44? I won't work out nice. Never mind. Ignore me. 2, 10, 5, 32 minus 4 is 28. So it works. Okay. So now it's a minus. So we're going to use the difference formula. So that's cosine of 330 minus 45 equals cosine 330 times cosine 45 plus sine of 330 times sine of 45. So cosine of 330 is root 3 over 2. Cosine of 45 is root 2 over 2. Sine of 330 is negative 1/2. And sine of 45 is root 2 over 2. So let's see what this gives. So that's root 6 over 4 minus, because that's negative, root 2 over 4. So root 6 minus root 2 over 4. Okay? We can do it with negative angles as well. The negative just tells us what direction to go. So let's turn negative 5 pi over 12 into degrees. So let's see. 5 times 180 divided by 12. Okay, that gives me negative 75. So sine negative 75, I could split that to be sine of let's see, I could do negative 45 minus 30. Yeah, that'll get a negative 75. So that's A, that's B, and we can use a difference one. Now we could, I've tested it out. We can do the sum and use negative angles. That's fine too. So let's see, what does this give? So sine negative 45 minus 30. So difference formula for sine is sine of A times cosine of B minus cosine negative 45 times sine of 30. So let's see. The negative 45, so on the unit circle, 45 is here. So negative 45 is going in the middle, but going the opposite way. So it's here. So negative root 2 over 2. And then cosine of 30 is root 3 over 2. Cosine of the negative 45 is root 2 over 2. And sine of 30 is 1/2. So I'll multiply these, and negative root 6 over 4 minus root 2 over 4. So negative, root 6 minus root 2, all over 4. I feel like it's the same thing. Crazy. Coincidental. We can also do tangent, everyone's favorite. Tangent. Okay. So 13 pi over 12 times 180 over pi, just so I can figure out the degree. So 13 times 180 divided by 12, that's 195. And let's see how I could get 195. I could break that into 45 plus 150, and it's a sum, so I could do tangent 45 plus 150, and that's a sum, so that is tangent A plus tangent B over 1 minus tangent A, which is 45, times tangent B. All right, so tangent of 45, so 45 is the root 2, and we're dividing the two, they're the same thing, so it's 1. And let's do tangent of 150. 150 is over here, and that's 1/2 divided by negative root 3 over 2, which is really 1/2 times 2 over root 3. The 2's will cancel, so negative 1 over root 3, which rationalize it, so it's negative root 3 over 3. So we get 1 minus root 3 over 3 over, and let's see, 1 times negative would be negative root 3 over 3. So then this double negative here would be plus, so 1 plus root 3 over 3, right? So now what we want to do is get into one fraction. So on the top, I'll have to multiply that by 3 over 3. I'm going to do the side work and move it up here. So I get 3 over 3 minus root 3 over 3. So as one fraction, that gives 3 minus root 3 over 3. Same thing here. It's going to give me 3 over 3 plus root 3 over 3. So as one fraction, it's going to give me 3 plus root 3 over 3. Now, both fractions or being divided by 3. So I can actually get rid of it. And now we have a radical in the bottom, so we have to rationalize the denominator, okay? This time, I can't just multiply it by root 3 like I'd done before. I have to multiply it by a whole phrase. 3 minus root 3. I'm going to do it in a different color because I have to FOIL it out. So 3 times 3 is 9. 3 times root 3. 3 root 3. 3 root 3. The negative will make positive, and root 3 times root 3 is just 3. So my new numerator, you know, I'm out of room, so I'm going to go over here, is 12 minus 6 root 3. I'll do the other one in blue. 3 times 3 is 9. That's negative 3 root 3. That's positive 3 root 3. And that'll be negative 3. The middle term with the radicals will cancel out. I'm left with 9 minus 3 to give me just 6. And then what I can do is I can reduce all of these numbers by 6. So that gives me 2 minus root 3 over 1. And 2 minus root 3 is our answer. Okay. Let's look at some more. You can do it with negatives. Actually, for the sake of time, you can try that one. Let's get into this other stuff. So, condense it into a single expression and then evaluate. So, all right. Let's see. I'm going to see what formula this matches up with. So tangent, if this were to be tangent A plus tangent B, 1 minus tangent A times tangent B, it's going to give the sum. So tangent of A plus B, well, A is 48, 102 is B. So I can add them. So 48 plus 102 is 150, and that's an angle on the unit circle. So tangent 140 or 150 is 1 over 2 divided by negative root 3 over 2, which is really 1/2 times 2 over the negative root 3. Those will cancel, so negative root 3 over 3 because I rationalized the denominator. All right. Let's see, cosine A times cosine B minus sine A sine B matches up with the cosine one. So cosine of A plus B, that gives me cosine of 315, which is also on the unit circle. And the cosine is the x value, so root 2 over 2. Let's see, this is a tangent one. Has a minus, so it's probably the difference. So tangent 5 pi over 18 minus pi over 36. This one might be easier to maybe do as it is, because 5 over 18, to get that to 36 would be 10 pi over 36, because I would just multiply both by 2. And then 10 minus 1 is 9, so 9 over 36. And that reduces to 1/4. So pi over 4. So tangent of pi over 4. Well, pi over 4 is this one. We got root 2 over 2, root 2 over 2. So tangent is just dividing the 2 and you get 1. All right, let's see. Sine, cosine minus cosine sine goes with sine of A minus B. Interesting. Let's get it to have a denominator of 30. because this one I can multiply by 3. So I multiply by 2. So then I get 35 pi over 30, which reduces to 7/6 if I divide those both by 5. And then sine is y at 7 pi over 6. So negative 1/2. All right, let's simplify these and see what happens. All right, let's see a cosine, cosine, sine, sine matches up. Cosine, cosine, sine, sine.
The word for and not
With it being plus is a cosine A minus B, where A is 2x, B is 4x. So cosine of 2x minus 4x, and then you get cosine of negative 2x. But remember from our identities yesterday, cosine of a negative angle is actually the same as if it was just positive. Okay. This is tangent, and it's a sum, so tangent A plus B. Well, A is 4 theta, B is just theta, so that is just tangent of 5 theta. So I should do that. All right, last one's here. Sine of pi over 2 cosine minus cosine sine goes with sine of A minus sine of B. A is pi over 2. B is alpha, which there's mine. So sine pi over 2 minus alpha is the same thing as cosine of alpha. It's from the identity from yesterday. All right, tangent 1. This is minus. It matches up with tangent A minus tangent B. So A just happens to be y. B is pi over 2. So tangent of y minus pi over 2. I can actually take out a negative and do tangent.
Almost 900,000. Some of these sources are about space tourism, but many
And then
others
if I
are not.
rearrange that
They have
order,
words tourism and space in them, but not necessarily together as space tourism. So for example, this
that
result is about
looks
tourism
very
space
similar
in Singapore, definitely not about space tourism.
to if
In
that
most
was
databases,
negative
you can eliminate
tangent
irrelevant results like
of
these with what
pi
you
over
call
2
raised
minus
results.
y, which
But
is the
putting
same
quotation marks in
thing
front
as
of the phrase
negative
you want to search, you're
cotangent
asking
of
the
y.
database to search for that exact phrase as you type it. Searching
And
for
all
space
right,
tourism
there we
again,
have it.
this time